Okay, so welcome everyone. Here we are, March, coming into spring. Glad everyone was able to attend. So just as a review, these meetings for any new folks here today, these meetings are every third Thursday of the month, 2:30 to 3:30. This Zoom link here will remain the same. I include that in emails. If anyone is not on the email distribution list for these meetings, please, please let me know and I'll add you to the list. We've had a number of people this last month that I added to the list. So if there's anyone else that needs to be added or anyone you know of that needs to be added, please be in touch about that. So just a reminder that we are working with groups that are directly associated with the Delaware River Watershed Initiative, but we're also supporting groups that are just working in the Delaware Basin but are not associated with DRWI. So keep that in mind if you're working with anyone that wants to attend, but they're not directly associated with DRWI, we can still work with you and support you. We are supporting via DRWI funds, but we're also supporting via Seesaw funds. DRWI, if you have any questions about that effort, you can go to this website. It is a William Penn Foundation project. And then Seesaw is a PADEP project, and that's associated with Growing Greener. So, by support, I mean these monthly meetings, I mean a lot of stuff that Shannon and Rachel do out in the field, our workshops, training events, all of our support is, sort of supported by those two methods. So these meetings, goals for these meetings are at the very foundational level. It's just time and space to check in, ask questions and report issues and just network and see what other folks are doing. And also to get updates from the Stroud Center, as well as to get some, specific information about certain topics via these presentations that we're doing each time. So here's our facilitators, Shannon, Krista, Rachel, and myself are all with the Stroud Center. And then we've got Carol Armstrong and George Seeds, who are both experienced master watershed stewards with the Chester and Delaware County group. As I mentioned, the meeting is being recorded, just FYI. All the meetings are, the recordings as well as the presentations are being are online and accessible, and I'll share those here at this website. This not only has these meetings, but it also has a lot of other good support materials, the manual, quick guides, all kinds of other materials. So this is our general format for the meetings. This intro I'm doing right now, presentations, updates. I'm going to be doing the updates after the presentation by Sarah today, and then we just have discussion and conclusions. So this is our agenda today. Sarah Damiano with Stroud is going to be doing the second part of the turbidity conversation. She's going to be talking quite a bit about our internal efforts to process and begin analyzing the turbidity data. So she's going to get into some details about what she's really been doing as one of the real kind of people that is immersed in data on a regular basis. So our primary goal with all of this support to EnviroDIY users in the Delaware Basin, a primary goal is to just support station owners and managers and the volunteers with using the stations for your own purposes, whether that's education, whether that's research, whether that's outreach, whatever, and working with you to support those efforts and develop and expand those efforts with the overall goal of building your capacity to do what you want to do with these stations. And then our secondary goal, which is kind of ties into what Sarah's talking about today, is analyzing the basin-wide data set, Stroud internally analyzing the basin-wide data set, and based on what we find with that, potentially and hopefully integrating some of the findings into methods by which groups can better characterize their own watersheds according to patterns and possibly thresholds that we establish throughout the basin. And that relates a lot to the type of stuff that Juniper Leifer and Christine Rogers, primarily Christine, is the lead on that effort, but who both presented their work a couple months ago. So that's the intro. Any questions at this point before we move on? All good? Okay, so we've got Sarah Damiano to talk now. She's a research technician at the Stroud Center. She's been there for quite a few years. As I mentioned, she is primarily involved in just the real heavy duty data analysis. Sarah also supports EnviroDIY with the programming of the mayfly boards for the EnviroDIY stations. And she's also really doing a lot of the data processing that we're involved with using her skill set in Python and other software. So I will stop my share and turn it over to Sarah to share her screen and begin.
And is everyone now seeing a big screen of what is turbidity?
Yep, yes. Looks good, Sarah.
Okay, so again, we're talking about turbidity. USGS defines turbidity. It's a measurement of the relative clarity of liquid. It's an optical characteristic of water. It's a measurement of how much light is scattered by materials in the water when a light is shined through it. So the more light that's scattered, the higher the turbidity is. Some of the things that cause turbidity include clay, silt, small organic particles, algae, some dissolved compounds, plankton, other microorganisms. This is just a cool picture, a NASA picture of two rivers merging, one carrying in large amounts of sediment and mixing with a less sediment-rich river. So why does anybody measure turbidity? So all by themselves, turbidity measurements aren't necessarily especially useful. It does tell us about the amount of light available to plants for photosynthesis. But really where turbidity is interesting is that it's a really valuable surrogate that gives us a lot of information about other water quality parameters that are very difficult to measure directly or continuously, such as sediment concentrations, which relates to local erosion rates, heavy metal concentrations, because heavy metals tend to stick to the sediments and are moved downstream primarily on the sediments. And in the same vein, concentrations of several types of pathogens, bacteria and protozoa that stick to particles moving downstream. So then what do you measure turbidity? So for those of you who have turbidity sensors, these sensors are some of the most expensive and most difficult to maintain sensors. So if you have one, you kind of should know why you're going through the trouble of having it. Some reasons you might have it, you might be using it as an educational tool to demonstrate your data or to teach people how to maintain a station. You might have a sediment or nutrient related total maximum daily load that's applied to your stations that you're monitoring to ensure compliance. You know, you're trying to verify that a remediation or restoration project is working, or you might just be trying to contribute to the research that we do at Stroud and other organizations within the William Penn Foundation do. So measuring turbidity. So how good does our turbidity data need to be useful? So really, it depends a lot on why you're measuring it. If your primary reason they have a monitoring station is to use as a teaching tool, you might have pretty high tolerance for bad data. If you're working with a legally mandated TMDL, you need some pretty excellent data. How do I know if my data is good? Well, the ideal is that you regularly measure the turbidity of the stream with a second independently certified turbidity meter that is calibrated against a known certified standard, and make sure that your sensors ratings match up with your handheld meters ratings. So see a plot here just showing we've got a couple of handheld readings and they're matching up fairly well with the turbidity measured by a sensor. In addition to the very expensive handheld calibrated meters, you can get a relatively inexpensive turbidity tube or a Secchi disc that can be used at moderate turbidities. This particular one can be used from 0 or low turbidity to about 120 NTU. Another option for verifying your data is you can actually install 2 completely independent sensors in the stream to ensure they match each other. This is a site on the white clay outside our back door at Stroud where we have 2 sensors deployed. One that's being shown in the blue dots is a Campbell OBS3, same sensor almost all of you groups have. And the other is a YSI sensor in orange. And you can see they really match up pretty nicely. I zoomed in on one of those peaks so you can really see it's pretty tight there. And that's good. So how do I know if my data is good? So in addition to independent measurements, we also know pretty well how most streams turbidity changes from day to day. So we want to make sure that our sensor values match up with expectations. So what do we expect? Well, we expect turbidity to be fairly low at base flow, to rise in a storm when the water rises, and then to fall back about to the initial level after the storm. So you can see this is a plot. I've got precipitation at the top coming down. I've got turbidity in the middle and stage or water depth at the bottom. So you can see it's fairly flat. We've got a large rain event. At the large rain event, we have turbidity going up. We have the stage or the water depth going up, and then we go back down to base flow. They follow each other fairly nicely. We may also see some seasonal variation in the turbidity. It's higher in the summer, generally lower in the fall and winter, but this variability is much less than what the variability you'd see in a storm. So this would have 2 years of data. This is from White Clay Creek, and it's actually plotted on a log scale to really accentuate that base flow difference. And here the base flow difference is only 2 to 3 NTU, unlike the hundreds of NTU change you're going to see in a storm. Other patterns you might see, larger streams may have higher base flow turbidity than small streams. It's going to be very situationally, it's going to depend a lot on your specific situation there. There's a lot of noise in that. And again, that's going to be a smaller influence than the storm patterns within a site. But generally, we know with turbidity that the stream isn't changing much. The turbidity should be pretty constant. Again, here, grabbed another period of time where I have almost no rain. Turbidity should be nothing happening. Stage or water depth, nothing is happening. So what do I do when my turbidity data doesn't match up with our standards and expectations? Well, you got to clean it up. You got to delete the bad or suspect data. You got to correct for drift and fouling where possible. Try to work it into a data set that you can really use to make to draw some solid conclusions. Internally, for a lot of this data QC, Stroud uses a software called Aquarius or Aquarius Time Series, which is made by a Canadian company called Aquatic Informatics. It's very nice software. Unfortunately, it's also very expensive software, but that's what we use internally. So step 1, when we open up our data set, the first thing we want to do is just remove obvious errors, things that are just sensor malfunctions. So we know that turbidity can't be less than 0. And we know that the turbidity sensor, the Campbell OBS3 that almost everyone has, we have the purchased in a 0 to 1000 NTU range. So if we see points that are either less than 0 or over 1000 NTU, we can immediately throw it out because we know that's just junk. This is a clip where we had the OBS3 max at 1000. We had a couple points that are up there, 7000. Those are just sensor blips. We can just ignore them. At the same time, most of you, if you monitor my Watershed, you'll probably be familiar with seeing a lot of -9999 values, which is what all our loggers report when the sensor isn't responding. You can just delete those values right away. Next thing in removing some obvious errors is to go back and look at your station notes. If we know from our maintenance visit that there was a period that the sensor was buried or that the sensor was dry, we can just throw that out right away. So this is where that EnviroDIY field visit data form is really helpful. It's really important to take good field notes, and we appreciate it very much when you submit those to us. As far as buried sensors, usually a buried sensor will sit at around 1,000, and a dry sensor might report negative, but it's not always. All right, so now we're going to look at our data. So first we want to start calibrating our eyes to what good data is going to look at our site. So first, we suggest focusing in on a period at your stream when you know the sensor was completely clean and operating properly, likely right after the sensor was installed. So this is a clip from a site right after it was installed. It's very clean data. Now we're going to zoom in on just the first couple days from this same clip here. And we want to make note of what the base flow turbidity was in this nice, clean initial period. Was it 2? Was it 5? Was it 30? And you want to kind of get an idea what it is, because that's a number that you should probably be seeing almost all the time, except during storms. This particular site, we zoomed in, it's hovering around 2 NTU. Not all sites are the same. This site is. Now we're going to move back. If you remember here, we have a couple of small storms. We're zooming in on those. So we want to calibrate our eyes to what a storm looks like. So if we have a small or large storm in a period when we know our sensor is top notch, we want to make note of how high the turbidity got, maybe whether it topped out before or after the flow, the water height did, and some idea of how long it took to come back down to base flow. In case of this particular stream, our turbidity topped out at around 175, and we were back down to base flow in about a day. That is the exact numbers for those are going to depend very much on your individual stream, but you need to make note of what it is for your stream. In this case, we're about 175 and down in a day. Okay, so now we have an idea. What could turbidity look like in general? What does turbidity look like in an ideal period in my stream? Next step is just to start going through our data. So once we've removed all the blatant errors, we know what we're expecting things to look like. We just basically step through and pan across our data day by day and look for anything that doesn't follow our expectations. Find if we have a reason, in our notes, it might not follow. We can account for that. And then we just start picking data and saying, this is good data, this is bad data. So what am I looking for? And when I'm evaluating data as I'm panning through? Well, first thing I'm looking for is just outliers, single or small numbers of points that are just way lower or way higher than any points before or after them. Usually this is just a fish or a leaf or some sort of electrical noise. And it's just delete those points. So you can see this turbidity data is fairly smooth. We have this one random point that's just popped out of nowhere. We just delete that point. In this case, we also immediately after see what looks like the sensor was buried in a storm. That we're going to delete that section as well. So again, a buried sensor. We're looking for signs that our sensor might be buried because it happens. So one of the big clearest signs of a buried sensor is if your turbidity goes up during the storm and doesn't come back down. So usually means that when you see that pattern, it usually means your sensor had a layer of dirt on it or was completely covered during the storm and you just want to delete it. So here we're looking at a site. We have 2 storms about 2 days apart. During the first storm, we see that our turbidity went up and down approximately with the stage. Looks good. We have a clear pattern. They kind of follow each other. And then the second smaller storm, the turbidity gets a lot higher and it gets really noisy and doesn't really follow anymore. That's a pretty clear sign that that sensor is probably buried. Other things to look for is a non-responsive sensor. So in this case, turbidity data that's very low or isn't changing when the stream stage changes. This again could mean your sensor is buried, or it could just mean that your sensor is dry. The stream has moved and your sensor is now measuring the air. So in this, I have another clip where we have, again, water depth or stage at the bottom, turbidity on the top. We see 2 storms, and the first one, there's absolutely no response from the turbidity. And the second one, we have a very noisy response. Could be that the sensor was buried and then partially cleared by the next storm. But either way, we're going to have to delete that data. So what else am I looking for? Fouling on the sensor. So that we're looking now for data that just begins to creep upward. It's not a storm, it's nothing happening. It just kind of starts creeping upward. And this upward creep is usually caused by algae growing on your sensor or dirt depositing on your sensor. And in all stations, this is by far the biggest reason that we end up deleting data. In some stations, depending on your situation, fouling can happen very, very quickly. Those of you who watch your data online, sometimes it feels like, I'm sure you clean your sensor and before you get back to your car, it's already starting to foul. Whereas others might get lucky and not have fouling for several months even. So minor fouling, if you see a drift upwards of less than 10 to 15 NTU, and you have a good value right after a cleaning at the end, you can actually correct that. We apply a linear correction to just pull that back down. So here the change, we have a cleaning. It changed by only about 2 NTU. So I just applied a linear correction. You can see that green line is the raw data, and I just pulled it down just a little bit to make it connect. But that's minor fouling. We also have a lot of major fouling. So if you see a large drift upwards and you don't know when the next cleaning is, you're going to have to just delete the whole section. This is by far the biggest reason we delete data. So in this case, another clip, we've got our turbidity. We see it's just starting to climb up. We have a cleaning, and then we suddenly have our turbidity plummet by about 20 NTU. Well, I showed you, if you see that dotted line in orange, that's what, if we tried to apply that linear correction, we suddenly would be dragging our turbidity down to less than 0. We know that's totally not valid. It's just too big of a change. We don't know what happened. We're just going to have to delete that data. So you're probably looking at this and thinking, yikes, I'm going to delete tons and tons of data. I just want you guys to know that it happens to the best of us. So this is an image of a couple months of data from a station that is a Stroud monitoring station not far from us. We actually have 2 sensors deployed at it. We still ended up deleting several months of data. You see that whole chunk of data, we had 2 sensors and we didn't get any good data from any of them because it just didn't get out there, didn't get it cleaned. We ended up losing the data. So if you feel like you're deleting tons of data, trust us, we understand. So, but of course we don't want to delete data. So how do we make it better in the future? Well, first, we do need to know how good our data needs to be, why we're collecting the data. Again, if your goal in collecting data is just to teach people how to collect data or to demonstrate something about your stream, you might have a pretty high tolerance for some of that fouling. Whereas if you're working on a TMDL, you need to keep it clean all the time. And all your data cleaning and your quality control is just going to be so much easier if the data you collect with is better to start with. So as you might see from photography, photo editing is no substitute for photography technique. Like if you see this almost adorable picture of my kids, except that no amount of Photoshop is going to fix the fact that my daughter is looking the other direction and my son is completely out of focus. So really the best way to get good data is to have your data be good to start with before you even enter the QC process. So how do you make it better? Maintenance. Best way to get better data is to visit your station and clean the sensor more frequently. There's just no way around this. If you want better data, you have to be there. You have to be maintaining it. So how do we No, everybody has a finite amount of person power. They can't be living at their stations. We can focus our visits on times when the sensor is most likely to need cleaning. First, you want to clean it right before a storm. Storms are when the excitement happens. So get your sensor ready to capture something exciting. Next time you might need to clean it is right after the storm, because the storm usually buries the sensor. Or if the sensor is going to be buried, it's going to be buried during a storm. So you want to visit and clean your sensor as soon as the water is gone down and it's safe to get in there. Other times you might need to clean more often is in the springtime, like right around now. As the weather and the stream water get warmer, algae is going to grow faster. Algae is one of those things that just grows on your sensor, causes it to foul. And before the leaves actually come out on the trees, which is not until early May, the stream's getting lots of extra sunlight. So it's getting all the sunlight, it's getting warm. The algae can grow really fast. You might need to clean it a lot more often. Also in the fall, you're probably going to have to clean more often. The turbidity in the stream actually does go down in the fall, but the fall, the stream ends up full of leaves. And when those leaves hit your sensor, you're going to not be able to use any data. And of course, other time to clean your sensor, you check, monitor My Watershed frequently if your station is reporting data online. And anytime you start to see your data creeping upwards or stuck at a high value or flatlining, that's when you just need to get out there and clean it. That's a lot, I know. So maybe you're not sure if you can handle that much work. What are my options? Well, first, if you can, recruit help. Find more volunteers, more workers, just pass the work around. Another option might be to purchase more expensive turbidity monitoring equipment that might have some sort of integrated self-cleaning. Some have things like a compressed air that will blast the sensor. Some have wipers. You can also get covers and screens to protect your sensor from cleaning. This is just an image. This is not of the turbidity sensor that any of us have. This is just showing that whereas got a sensor package that's completely covered with algae and yuck, the viewing window of this turbidity sensor is clean because it does have a wiping brush. Another thing you can do is you can get a sensor with a shorter field of vision. That's going to help for help reduce some of the impacts of fouling that are caused by the sensor being buried because it doesn't need to see as far. But do keep in mind, no matter how awesome your equipment is, no matter what fouling protection you have, you still are going to need to make maintenance visits to your station. Even the best equipment needs to be maintained. So what are some other options? Well, one thing you can actually do is consider a temporary deployment of your turbidity sensor. Instead of putting it in the stream, leaving it in the stream all the time, you can actually deploy it for a little bit of time and then take it out. So you can temporarily deploy it, aiming to capture just one storm or a small number of storms, and then take it back out, wait until the next storm is coming in on the Weather Channel, put it back out. And so if we can capture a few good storms, we can actually do we can look at the relationship between flow and turbidity in those storms that we have really good data from, and we can use that to estimate the turbidity for the storms that we don't get. There's a lot of noise in this relationship. This is actually looking at the natural log. So we've got a log axis on the bottom, and actually it's a log. But we're looking at white clay data here where we're showing flow against it. This is actually sediment concentration. And you can see this is, there's a lot of scatter, but if we can get even a couple storms, we can get some relationship and we can use our data, use our depth data to estimate what we might be missing with only deploying our turbidity sensor temporarily. And then as a last resort, if you really don't think you're able to do this, you might need to consider whether you need to measure turbidity at all. And if not, remove the sensor. That's a last resort. We don't want you to come to that, but it might have to, or it might be the reality of your situation. Okay, so we showed a lot of really fast data on turbidity. So I told you that we're evaluating the turbidity coming from all of your stations. And do I have any results? Truth is, it's very much a work in progress. But two of the more photogenic plots I have for you. One, we're looking just at the rise in turbidity over a storm, where we have just the rise in the storm plotted against the percent cover of natural. It's well into forest, is not ag, not developed. We can see that we have a lot of noise, but we are seeing some relationship where we're getting a larger rise in turbidity during storms in more developed, less natural areas. And then on the right, I have exactly the same points just plotted on the map so you can get an idea of where those stations are. Sorry, going a little fast. So last, where do I go for more information? Well, Dave Bressler is going to be your best resource. Also, if you go on to wikiwatershed.org, there is an awesome help page. If you click on the help, scroll down to find the Monitor My Watershed and EnviroDIY, click on the View Help Resources, and you'll get the Sensor Data Help, which has links to the awesome manual that Dave and Rachel have especially put a lot of time into for all aspects of station maintenance. It's also some of the quick guides that we've had. It's links to these videos. That's all going to be there. Also, if you go to EnviroDIY.org, we have a forum where you are welcome to post questions and hopefully get some answers in a public way so that you can help everyone else, because chances are if you have a question, someone else has the same question. And now, speaking of questions, I think we can go and I can stop that sharing and give everyone a chance to ask questions.
Yeah, so if anyone has any immediate questions, we can do that. Anything popping in people's minds right now to ask Sarah right off? Jim Moore, you're muted.
I'm unmuted now.
Okay.
A question about the wipers. My experience with the turbidity sensors, the biggest problem is algae forming on them, and you just have to wipe them off and they seem to go back to normal. But do we have any experience with the wipers? I think somewhere I saw somebody was working with that. Yes.
Certainly there are wiper turbidity units sold. At the Stroud Center, we have a number of YSI units, which are wipered. They definitely do foul less. They do, even with the wiper, however, they do still foul. They do still need maintenance, but it definitely does help a lot. But of course, that's at the expense of, well, the instrument itself is going to be more expensive, and it's also going to take a lot more power to run the motors to clean it. So they help, but they're trade-offs.
And to follow up with that, to my understanding, there's also, there's plenty of turbidity sensors out there, but there is variability in how well wipers work from sensor to sensor. That is, I think some of them, and Sarah, you can speak to this probably, but some that have been tested, that we've tested, the wiper doesn't really even work that well because it just smears stuff instead of removing.
Yeah, well, that's definitely true as well.
Has there been any sensors that use some algicide? I know I talked to some professor, he said just squirt a little algicide over the lens and that will clean it. Whether you could have some sort of dispenser that would dribble algicide over it. Are there any?
So I haven't seen some that have an algicide dispenser, but that doesn't mean they don't exist. I just haven't used one. We do have a different type of optical sensor that we've used that used a compressed air to blast it. People have tried a lot of different things. Some cases, like basically instead of wipering it, you can add a clamshell to clap over top of the sensor to keep it covered, and then only open it up when you're taking a measurement. depending on your sensor. Some people have had good results by even just adding a simple copper mesh screen because copper is less attractive to algae. So yeah, there are definitely things you can do to reduce fouling, as long as you understand that all you're doing is reducing it. You're still going to need to get out there to clean the sensor.
Yeah, okay, thank you. Actually, I did try silver. I used some of our family's silverware. That didn't work, so silver, copper.
I haven't seen silver. I have seen copper, the DO sensors. A few people I think have ZebraTech brand DO sensors deployed. Those have a copper element right around the sensor, which helps to reduce fouling some. I'm not sure I've actually seen people using silverware.
Well, I was told it might work. It didn't, so.
Hey, Dave, this is Steve Tricarico. How you doing?
Hey, Steve.
I have a question on our sensor here on the unnamed tributary on Plum Creek. I actually have two graphs that show up, and I have two turbidity listings. I didn't think that there's two separate sensors, but the one is like kind of recently has gone off the map. I mean, it's just all over the place. But is that two signals that are coming in independent, or is that, I'm not really sure what type of device we have since I'm getting two turbidity measurements.
You're talking about the Campbell OBS 3 Plus, right, Steve?
Campbell, yes, that's correct.
Yeah, that's Sarah or Shannon, do you want to address that?
Sure, that's just the way the sensor works. It can work in two different ranges. And the way the sensor works is that it actually reports out on two different wires, whether it's in a lower range or a higher range. The lower range is 0 to about 250 NTU, and the higher range is 0 to 1,000 NTU. So even if your low one is sitting topped out, that's a pretty good sign that your sensor needs to be cleaned. But both of those numbers are coming from a single sensor. It's all being measured in the same way. It's just electronically how it's ranged and converted and read into the Mayfly that it comes in as two separate channels.
Yeah, that makes sense when I look at the two different graphs, because the one, like you say, tops out and then the other one takes off, goes way above it.
Yeah, so they should be generally at low flow or at low flow and low turbidities, they should be almost identical, but
And they are, yes.
Yeah, but because the low range tops out at 250, you'll sometimes see that one pegged and see high numbers on your other range. If you're sitting at that high value though, that means your sensor is dirty and needs to be cleaned.
Yes, I'll get out there and take care of it. Thank you.
Dave Yake.
Sarah, thanks for the presentation. When I looked at how you were trying to correlate your data, I noticed you were correlating turbidity versus flow rate or some surrogate of that.
Yeah.
Is that and there's a lot of variance, of course, with that correlation. Would it be advantageous for your analysis work to have a correlation that had lower variance with some kind of relationship?
Well, so right now I'm looking, well, there's going to be noise in that relationship because there really is in nature. Right now I'm looking at water depth because that's what I have. And I know you've spent a lot of time looking into the relationship between water depth and actually getting the flow measurements. And ideally for the analysis, if we want to look at loads, we would need that. I just haven't gotten that far. It's to actually trying to get to look at flow. So right now, when I'm doing kind of base level corrections, I'm just looking at depth. So
I see, you're looking at depth, gotcha, as a surrogate for flow then.
Yeah, I'm looking at depth, and when I'm looking to correct turbidity data, I'm really not looking at it in the sense of exactly what the correlation is, rather than that for a starting pass, I'm just looking to see that they're following the same trends. So once we're not far enough down the analysis path to be doing discharge relationships yet. Yes, that would be awesome to have, but we're just not far enough into the analysis yet.
Well, what I was wondering is if there was a way to do the correlation where you did not have to have a discharge curve, you could estimate it basically. The correlation would include that automatically. Would that be something helpful where it would cut across different watersheds as long as you knew the width and the depth at some point?
Well, so you're talking about you measuring, you're estimating discharge.
Yeah, would you estimate the discharge, have a way to do it automatically without having a discharge rating curve, essentially?
Oh, well, yes, so yes, that would be very helpful. It's essentially you're calculating what the rating curve would be rather than physically measuring it. And yeah, and that would be awesome. Well, I was just saying that we're at the stage we are at in analyzing the watershed turbidity data. We're not even ready to handle that yet.
Right.
But Dave, it might make sense, at some point, because I know you do have the capacity at this point to generate rating curves with just a bit of, our initial cross-sectional information and that type of stuff. So, and that's something we've been kind of rolling around, is when to sort of move on that. But maybe really, if we presumably will get to that point at some point, and certainly would be tremendous to have rating curves for all the sites, because it certainly would make things a lot easier in terms of some of the sediment question types.
Right. I guess the follow-up question, Sarah, which depending on where you're headed with the analysis, is, are you more interested in the amount of sediment or average turbidity in a storm, or are you interested in base flow conditions that would have elevated turbidity, real elevated turbidity?
I don't know if we're even sure what we're interested in yet.
Well, I mean, I think broadly it would be storm related, Dave. I don't think we're probably trying to be looking at subtle turbidity variations during base flow, but I think it would be any turbidity or sediment load or sediment concentration information that would be useful in the broader context for stations or groups with stations to be able to place their site in some sort of relation to, other sites, that being sites that they may be comparable to or sites that may be better, that they could kind of look to as good examples, and or sites that are worse that would be sort of, the other end of the.
Right, but your interest would be relating that to what's going on in the watershed at that location, right?
Exactly. So that it's a guide, it's a guide that someone in a watershed could use to kind of sleuth issues and sort of, do outreach and talk with managers and decision makers to try to move on according to what data may be telling you.
Right, and what you'd be looking for is something that's relatively simple to implement without too much complexity.
Absolutely, right? Absolutely, yes.
Yeah, I'll look into that, see what I can do.
Okay.
Yeah, Jim.
Yeah, I thought one of the big issues with the turbidity was to look at bank and stream bank erosion, sort of correlating that with stakes or whatever they use to see how much particular streams are eroding their banks.
Yeah, I mean, that's a pretty lofty goal, because there's so much, usually there's a whole lot of watershed that isn't being sort of, assessed. And
let me interrupt you, Dave, so you don't go too far down that. Jim, what you've been hearing is basically a marketing message from people who have heavy equipment looking for stream banks to bulldoze. What we're looking at is the overall watershed disturbance and asking how much erosion is occurring in this 100 square kilometers or 10 square kilometers or 1 square kilometer. And is it in excess? You're especially looking for your site being out of the norm and therefore excessive field erosion. That's where the sediment is really coming from. on the reverse side, when you get urbanized and you cement up your watershed, much of your sediment is actually tied up and you're starving your stream of sediment. You do see bank erosion, but that's in part because no new material is coming into the stream. And so the stream is grabbing from the banks because it can't get new sediment coming from the watershed. So we're looking at it as an overall measure of disturbance in the watershed. But there's another thing you want to keep your eye on, especially if you're focused on an issue, and that is when you have active construction and you're cleaning the data, you have to remember, what do construction companies do? And that is they pump their work sites to work in them. So if they've got basements or holes dug or whatever, and it rains over the weekend, first thing Monday morning, they turn their pumps on. You'll see little or no change in the base flow, but you'll see a pile of silty water come through your sensor, as an example. That's the kind of thing you're looking for, in part because at low flow, that silt settles out very quickly and causes far more stream damage than maybe your stream event does, because you've got this higher volume of water with greater velocities, and it moves things along, or even has the potential to deposit it up on the banks. So when you're in an environment where you have active groundbreaking, you need to pay attention to peaks that occur Monday morning, peaks that occur at 7 a.m. that clearly look like somebody's pumping their website or their work site free. And Dave Bresler and I were both watching that happen repeatedly in the last few years. We were amazed, and to my knowledge, they weren't doing anything wrong, but the stream got silted up at a base flow from site pumping virtually every day after a rain event. And then there would be smaller events that didn't result in any pumping, and the stream would clear out again. But in the meantime, you were burying it. So those are the kinds of things you're looking for also. But it's mostly a measure of broader scale watershed or field erosion that's making its way to the stream.
Good, thanks, John. Carol has a question.
Thanks. Sarah, thank you for your talk. It was very helpful. You had a really interesting graph at the end showing that there is some correlation with higher levels of sediment, or I should say higher levels of turbidity in more human impacted areas. Is that right? More impervious areas.
Yeah.
And so I was wondering, how much of, does anyone know whether what is the relative contribution from a greater amount of riparian sediment versus all of the junk on the road from the vehicles and the tires and all of the road sediment, the road sediment, because the road sediment, cleaning that is a DEP measure for municipalities to meet their MS4 requirements. I mean, it actually makes a difference in the amount of sediment going to the stream. So does anyone know whether it's more or less or equal from the roads versus the riparian sediment, where there's less forestation and less, stability of the riparian areas?
I've never seen the balance. Someone may have done it, but what they do know is that they know how much in tons that they're able to remove, that if they didn't do it, that would end up in the stream. And that's part of the battle for using traction enhancers versus road salt, is they went away from sand and grit because it ends up as silt in the stream, but instead they replaced it with a toxic load of salt. So that's part of the discussion, which is better, which is worse. But one thing for sure is you can sweep up a lot of the grit, actively control it. Whereas once the salt's out of the truck, there's no way of bringing it back in. So I imagine that conversation is going to go that way. but I've never seen the mass balance that tells me how they rank.
The one thing I would add, though, is that Stroud has a tool that's part of the Wiki Watershed Model My Watershed. It's like, I think it's called like a stormwater model.
Mhm.
And I have calibrated that model with probably a dozen different streams on sediment for different rain level events. And that model is really good. It can, once it's calibrated, it can predict what a stream will be able to generate in terms of sediment. So that might be something that you could look at, Sarah, because I think it has potential to save some time and energy on your analysis, I believe.
So I actually have run the watershed model for every single site that we have within the DRWI range, both the citizen science monitoring stations and stations that people like John Jackson take care of, but we haven't gotten that far into the analysis yet. So yes, we're definitely aware of that, and I've actually done the modeling on all the sites, but I haven't gotten as far as doing individual calibrations or really doing much analysis on the results.
Yeah, it's pretty impressive model, frankly.
Oh, and the way Model My Watershed can do it is brilliant.
It's one thing people don't realize is one of the reasons there's so much attention to turbidity and sediment and so much finger pointing at it is because the modeling is just a hydrologic model. It's a pretty tight, and hydrology is the easiest thing to model in nature. It's rain down, water out, with a little evaporation added in. The problem that's resulted from that is there's been an maybe an overemphasis on sediment as a pollutant, whether you're in the Chesapeake or the Delaware. Sediment, and then nobody asks what's the mode of action. If we're going to point our finger at it, because remember, the Mississippi is a very muddy river. It's full of life. The load in some of your North American rivers are naturally quite high, and life does just fine. And so that's why much of your stream restoration work that was in-channel work that tried to lock everything down hasn't resulted in stream improvements. It is categorically a failure. Multiple studies across the board, and what that tells you is one of two things: they're looking at the wrong stressor, or they're doing the wrong fix. And my guess is they're related, and it's both. But it's been so easy to model and therefore give credits and things like that, such as in MS4 programs, that it's received way more attention than science can give it justification.
Good, excellent. Good information, John. Thank you. All right, so we are at 3:24, but Krista has one additional question. We better stop there so that we can do our poll and provide a few updates. Krista?
Yeah, thanks, Dave. So Sarah, you had mentioned like you guys use the software package Aquarius, but you also mentioned how it's kind of cost prohibitive. Do you have a process, or would you guys be able to create a process for, something that everybody has access to, like Excel for like basic data cleaning, if they want to take turbidity data and just clean it up so that they can look at their data trends?
So right now I don't have anything to offer.
I mean, Krista, I think
I don't.
I think to that point, Krista, with the point Sarah made about just focusing on getting a few storms, getting really good data for a few storms, and working that way can really be effective, especially big storms, because as we know, that's when most of the sediment moves, is
Right.
during the big storms. So, the base flow data, it's not, for most of our purposes, isn't that important, and it's really just the big storms. And then if you get big storms and you get a relatively good hump, a relatively good turbidity hump, but you've got a few you know, snags and fouls coming in here and there, that's relatively easy to correct manually, like in Excel.
Okay.
Yeah.
Yeah, and I mean, as with cleaning, I don't have a great tool to offer you that's not cost prohibitive for doing the quality control, but kind of like I said, doing all that quality control is going to be so much easier if you clean your sensor and have good data to start with, and also if you make good maintenance notes so that you know you can look at your notes and find out when the sensor was buried. I actually found a funny quote on a photography blog. Again, not quite the same, but the photographer was saying, you know, producing a good image from a poorly taken photo can take hours sitting in front of a computer. How long does it take to get it right in the first place? About 1/500th of a second. So obviously it takes more than that, longer to clean your sensor than it does to take a photo, but really the best way that you're going to make your QC work easy is by getting good data in the first place, by keeping your sensor clean and doing that maintenance and keeping a good log of your maintenance.
If I can
Those
add
are-
one thing that I was thinking about when Sarah was talking, when you're doing data like this, because you get buried really quick, even if you're just doing storm events, look at it, clean it, decide whether what you're doing is working. Do you need to clean more often? Stay on top of the data so that you're not suddenly decide to clean up 2 years of data, which is a frightening endeavor.
Yeah. All right. So before anyone jumps off, let me do this poll and then we'll do updates. We're going to have to stay a little bit later for any additional questions, but we'll do that. So I'm going to just do this poll, and if everyone could just take a minute to complete this, that would be very much appreciated. Okay, looks like we're getting there. A few more folks. We're 80% of the way there. Anyone else getting there? 20 more seconds. Anyone who hasn't done it yet, please do so. Looks pretty good. All right, so let me. Okay. All right, I will end polling now. Ending polling. Okay. There's our results to share. So it looks pretty good. Looks like people are fairly satisfied with the presentation. So that's good to see. So thank you for that. And so I will stop that. And I will share my screen and go through our final updates. If anyone needs to go, we understand, but we've got a number of updates. And I think Jim Moore had a few updates that he wanted to mention as well. And then after that, we can go to any additional questions that folks might have. So what I have here, I mentioned this last meeting, but this is an ongoing process. And Mike Hartshorn, who is with Princeton Hydro, is sort of running this project for Schuylkill River Greenways. John Jackson and I are contributing to this effort. And Mike is basically trying to recruit volunteers, you know, to do these visual trash assessments along the Schuylkill River. It's something you can totally do on your own. They are doing some trainings, but it is something you can just do on your own using your cell phone. It's very simple, but it is a concerted effort to document trash from Reading down to Philly on the Schuylkill River. And they're already having good results, and it seems like a really good project to, you know, increase, you know, usage of the Schuylkill River and sort of documenting where trouble areas are as far as trash as well as other things. So feel free to reach out to Mike if you'd like to be involved. You can also just reach out to me if you want, but any support would be appreciated on that. Patty Haug, who I believe is on this call, is a Master Watershed Steward and a Masters of Science student at Westchester University. She's finishing up her work there this semester and has a nice presentation that's going to be happening here on March 24th regarding her work on streams in Westchester, specifically related to salt issues. Here's the information. This information is also in the chat, so you can do that. And Carol, if you wouldn't mind reposting that at the beginning here, I mean, at our current spot in the chat, that would be much appreciated. The cellular board issues continue. Shannon and Sarah are diligently looking into technology improvements to help this issue. These are new 4G boards, and this is a new process that we've gotten involved with just in 2020, upgrading stations to 4G, and there's some issues with the technology. So Shannon and Sarah are looking into other options that may produce reliable cell connectivity. This is an important new advancement at Stroud, specifically in the Wiki Watershed Toolkit, Manage My Watershed. I mentioned this previously in the last month, but we now have 3 really nice case study type articles here. And I think the 3 articles that are posted are by people who are actually on this call today. The first is by George Sees, who works with Patty in the Westchester area on those streams there. This is an article by Carol Armstrong about salt pile issues, exposed salt pile issues. And there's a lot of good information there about actually like the process that Carol used to actually try to get things to happen. And it's a real back and forth process with the organization, with the municipality, with the state. And so she provides a lot of good information there as far as how to do that type of thing. And then Francis Collins, who did a presentation earlier in 2020 about the Primrose Creek quarry issues. Again, this is a really good piece that kind of describes on the ground work to enact change. And Francis provides a lot of good anecdotes there and a lot of just good kind of case study information over a long period of years of the processes that they went through to kind of help that watershed. So some really nice pieces there. And if anyone is interested in being involved with writing a piece for this, please be in touch. There's a section on Manage My Watershed that you can actually just propose something right there, and we can work with you on that. So that's what I've got for updates. There's some other tools here. I'm going to stop share though, because I think the rest of the stuff I have there is pretty stuff that folks know about. So I just want to open it to anyone else that would have additional questions or things to discuss. Anyone else have issues to discuss, questions for Sarah or questions in general?
Yeah, I had one World Water Day. I think I sent you a link for that. I don't know if you shared it or not. I didn't even know there was a World Water Day, but apparently there is.
Okay. Yeah. Let me see here, Jim Moore. Did you send me a link or anything like that?
Yes, I sent you something. I
Here we
can
go.
check it.
Yes,
It's
here we go.
basically temple, and a friend of mine is managing it, and they're putting on a dance, and somehow it's
That's
tied in
right.
with
I'm
water.
sorry, Jim. I was gonna make a slide up on that, and I did not manage to do that. Let me see here. So Jim, there's a dance going on that seems like a pretty interesting event. If anyone is interested in that, you can check World Water Day link that I just posted in there, and I'm sure you can be in touch with Jim himself or get in touch with me if you want me to put you in touch with Jim.
Yeah, the only thing is they ask you to buy tickets, so go ahead and do it, and the cost is $0. So
Okay.
they're cheap.
Excellent. And Sarah just posted in another link there to another link there associated with that event. So
Oh,
thank you.
yeah, okay. Yep, that's it.
Great.
Dave, one thing I would add is that the last 2 or 3 weeks, I've been doing a lot of work in developing some competency with the USGS mod flow process.
Mm.
And so if anybody at Stroud has some background in that, I'd sure like to know who that is, because it's a pretty tough program to learn how to use.
Any idea about that, Sarah?
I have not used it. I don't know if Melinda has or.
I don't know anything about it.
Yeah, well, if you're interested, I've simulated the Broad Run watershed with it in terms of the impact of production wells, but it's pretty tough. But I just thought I might share that in case you guys are interested. I'd show you what it is. It's not for the heart, though. That's for sure.
Dave, did you go through? There's a tutorial for ModFlow. You may be able to figure it out on your own. I couldn't, but I used the tutorial to learn it.
Yeah, there are, but unfortunately, I couldn't bring a lot of the slides up. It wouldn't come through on my machine, so I had to do it trial and error. And there's probably 300 or 400 different iterations you had to play around with. But
yeah. Okay.
Do you have experience with that?
Very minimal experience. However, my professor, Martin Helmke, he knows ModFlow very well. He might be someone to reach out to from Westchester University.
Okay, good.
Good. That's great information, Patty. Thanks. Jim?
Yeah, quickie, you said something about problems with 4G, and I just upgraded all 6 of my low-cost sensors with 4G, and I didn't have any problems. Everything worked fine. I was quite amazed. So what's the problem?
Well, I mean, Shannon can speak to it if she wants, but it's, as I understand it from what Shannon and Rachel have told me and Sarah have told me, is it's very situational, and some boards will fry very quickly or break very quickly, and then others you'll put out and they'll be totally fine. And there's not really a clear sort of cause at this point, which is why Shannon and Sarah are now really just exploring other boards and stuff like that, because it's been a challenge to figure out even why there is issues with some of the boards.
So quality control hardware problem rather than software or firmware?
Shannon, any thoughts on that?
We really have no idea, Jim. We were working with the Digi company to find out why. We've got a couple dozen that have failed that we're going to ship back to them soon, and they're going to take a look at them. So I don't have any update. We don't know if it's a hardware, if it's voltages, or if it's a problem on their end or software. It's just basically the modules are still alive. They are just non-responsive. There's 2 chips on the board, one cellular and one is the communication chip. And so one portion of the Digi XB will be responsive and the other one is not, and that keeps it from connecting to the cell network. So there's a lot of times where people will see their station has dropped offline, but their battery is still fine and they're still getting data on their memory card. It's just not connected to the 4G network anymore. And the only solution there is to replace the cell board with a new one. If your board is less than a year old, then it's covered under warranty supposedly, but it's not, we don't want to have to keep replacing them as often as we are. So we're looking into other options, and maybe next month or the month after we will have an update for people on that.
Okay, I'll touch base. I ran some current draw tests on the 4G. Very sort of interesting. So I'll get up with you offline on that.
Good. Thanks, Jim. Yeah, Francis.
Question about microplastics. I've had a couple teachers that we work with up here, and they've been reading about microplastics found in streams in Bucks County. And did I mishear or hear that Scott Ensign and Sarah may be somehow involved with the analysis of microplastics? And if so, was I just dreaming that, or did?
Not that I know of. Sarah, you're not involved with microplastics, are you?
I'm not. I haven't done anything with.
No, but Francis, we have we have someone on the call right now who really keeps up on microplastics and is actually actively doing presentations and such. Carol Armstrong, which I think you've met her before, but Carol is actively working on plastics and microplastics stuff, and she stays really up on issues. So I don't know if you want to say anything, Carol, but you guys are free to talk after the meeting. If Carol, if you want to work with Francis on any issues or questions that he has.
Yeah, I would love to talk to you, Francis, about it. We're closer to your neck of the woods. We have an initiative trying to focus on the National Wildlife Refuge. So we are preparing partners for a symposium. So we should talk. So I can find out more about what your interests are.
Very good. Okay, Carol. I will I'll reach out to you in the next day or two.
Yeah.
Okay.
Great. Good. That's great, Francis. All right, we are at 3:41. I'm impressed how many people have stayed on. Anything else from anyone? Any questions, concerns, issues, successes?
I move we adjourn. Thank you. Very
Okay.
good.
Thanks, everyone. Take care. Be safe out there, and we'll see you next month or sooner.
Right.
Okay, bye.
All right, thank you.
See you next time around.